Ponder this. What if there existed an artificial neural network that could approximate any continuous function on a bounded set with arbitrary precision, given enough hidden neurons? Well, that's not just a hypothetical. Such a network does exist, and it's known as Radial Basis Function Networks, or RBFNs for short. These fascinating networks utilize radial basis functions as activation functions. What's unique about these radial basis functions is that they depend solely on the distance from a center point. They can take on different shapes such as Gaussian, multiquadric, or inverse quadratic. Now, the world of artificial neural networks is a diverse one. For comparison, let's take multilayer perceptrons, or MLPs. At first glance, they may seem similar to RBFNs, but key differences set them apart. RBFNs, for instance, are easier to train. How so? They only require one layer of weights to be optimized. Additionally, they show a robustness to noise and outliers thanks to their local activation functions that are less influenced by distant inputs. And when it comes to handling high-dimensional inputs, RBFNs outperform MLPs, as they don't suffer from the curse of dimensionality as much. But it's not all sunshine and rainbows. RBFNs do have their challenges. They can be memory hogs, needing a lot of storage for the prototype vectors and the activation values of each neuron. They can struggle to generalize to new data that's outside the range of the training data because they rely on interpolation rather than extrapolation. And overfitting can become an issue if the number of hidden neurons is too large or the width of the radial basis functions is too small. In the realm of natural language processing, RBFNs have found their niche. They can be employed for a range of tasks, from sentiment analysis to text classification and even named entity recognition. Here, the relationships between words or phrases and their meanings are often nonlinear, making RBFNs an excellent choice. For instance, RBFNs can classify movie reviews as positive or negative based on the similarity of the review text to some prototype vectors that represent each sentiment. They can even identify the names of people, organizations, locations, and other entities in a text by comparing the input words to some stored training data that has examples of named entities. So there you have it, a crash course in radial basis function networks. Remember, these networks are not just an abstract concept, they're a practical tool, helping to navigate the complex and nonlinear world of language and demonstrating the power and potential of artificial neural networks.